Okay, this is question 27F of the 2015 CSSA General Mathematics trial. Now, this is a classic question where the scenario provided could be overwhelming for some candidates. But when you break it down, the mathematics is very, very basic. So I guess the reason I want to show this particular example is to show you that if you look behind the scenario, if you break it down, you'll see the maths is pretty basic. So it says the fuel consumption for Sandra's car is 14.3 litres per 100 kilometres for urban conditions. Her combined test fuel consumption is 11.4 litres per 100 kilometres. Extra urban conditions are freeway conditions. Okay, so now if you look at your table here, the fuel consumption table, this here, and obviously this one here, this is an average. And it's an average made up of the urban conditions and the extra urban conditions. Okay, so in order to find this, which I believe is what's happening here, so let's have a look. The fuel consumption for the combined test is the average of the urban and extra urban rates. Well, they're actually telling you what to do. Calculate Sandra's extra urban fuel consumption. So basically, to cut a long story short, what you've got to do here is find what, because you've got two items here that add together, and when you divide by 2, you get an answer of 11.4. That's it. It's as basic as that. So basically, you take the 11.4 to be your mean. So you can say the mean here is 11.4. Now, to calculate the mean, it's the sum of all scores divided by how many there are. So in this case, you've got 11.4 is equal to 14.3 plus the unknown, which is the fuel consumption in extra urban conditions, and divide by 2. Okay, well, simple equation now. Forget the scenario, forget everything else, just a basic equation that you've got to solve. So you've got to get x on its own, so multiply both sides by 2, and you get 22.8 is equal to, that cancels out of that, 14.3 plus x minus 14.3 to both sides, and you get x is equal to 8.5 litres per 100 kilometres. And that answer makes sense because, look, if you're finding an average between 14.3 and another number that gives you 11.4, clearly that other number has got to be less than 11.4. So you can be pretty confident that's your right answer, and just make sure you put it back into the context of the question. But hopefully you can see the mathematics is pretty basic there. Okay, Sandra travels a distance of 512 kilometres to work each month in urban conditions. How many litres of fuel does she use in a month? Okay, well, in this particular case, we know that the fuel consumptions are measured per 100 kilometres. So if you got 512 kilometres, what you're looking at is 5.12 100 kilometres. Now, each month. So, and it says here, each month in urban conditions. So in urban conditions, she uses 14.3 litres per 100 kilometre. Now, 512 kilometres means you've got 5.12 100 kilometres. That's 5.12 lots of 100. That's what makes the 512. That's just an extra step just to show you. So basically, to work this out, you know in urban conditions, it's 14.3 litres per 100 kilometre. So it's 14.3 multiplied by 5.12, because that's how many 100 kilometres you have. So when you multiply that together, you get an answer of 73.216. So litres, according to her fuel consumption, when Sandra travels a distance of 512 kilometres to work each month in urban conditions, she will use up 73.216 litres of petrol. Okay, now Sandra travels to work for 11 months each year. In 1 year, her car emits 816.64 kilograms of carbon dioxide. Calculate her rate of CO2, carbon dioxide, emission in grams per kilometre. Now, once again, people will get bogged down in this question because they think, oh, how do I, this just seems completely foreign. This is like a science experiment. But all it is, it's just a simple rate question. You've got, what they want you to do is compare the weight with the distance. Okay? Now, to work out the weight, what you've got here is kilograms, but they want you to have it expressed in grams. So 816.64 kilograms is equal to, multiply that by 1,000, okay? So you can just write 816.64 times 1,000. That's how many grams you have. And you want to compare that to the distance travelled. Now, the distance travelled, if you look back, it says Sandra travels to work for 11 months each year. In 1 year, her car emits that much of carbon dioxide. Now, in the previous question, and don't forget, these are all linked. In the previous question, it states that Sandra travels a distance of 512 kilometres to work, okay, and this is also to work, so that's to work, this is to work, each month. So basically, you're taking that as an average distance travelled each month. So to find out how much she's travelled over 11 months, it's just a simple case of 512 times 11, okay, which equals 5,632. So all you've got to do now is compare, I'll just put that in to get the rate. All you've got to do now, 16.64 times 1,000 over 5,632. Now when you compare that, put that into your calculator, you'll get an answer of 145. Now that represents 145 grams per kilometre. Okay, so and that's all it is. You're comparing the weight. So this is the grams, and you're comparing that to kilometres. Okay, and this is just another way of expressing a fraction, which is what you've got there. So 145 grams per kilometre.